Welcome to the shop. I'm continuing NQALHA Production Run 5 on my new Haas Mini Mill 2 and making good progress. The pile of parts continues growing. I'm making 20 units in this run because last run I made 10 and sold them all in a week. So I think there's a lot of interest going on here. Today I'm going to be starting to make drive rollers, and this is the highest quantity of any part. Each NQALHA has 8 drive rollers, so that's 160 drive rollers. It's a lot of drive rollers. So I've been trying to figure out, well, what's the highest production that I can do? And I'm using the array function that I talked about in previous videos, where the toolpath program BobCad automatically creates a duplicated set of toolpath with 4 different work offsets. And I'm trying to automate the construction of these work offsets to avoid error, where when I measure work offset 1, I know that work offset 7 is the array partner of work offset 1. So when I probe work offset 1, I automatically update the matching variables, which are Y and Z. And so the only thing that I have to set somewhat manually is the X variable, and I even wrote a little program to set the X variable so I don't have to type it in by hand. So I kind of spent the morning dicking around fighting BobCad, trying to come up with the most efficient toolpath I could come up with, and it seems like there are, so many places where the program just doesn't do what I expect it to do, and trying to figure out what's going on. The documentation is poor and incomplete, and I actually found an error in the documentation where the documentation claims that the retract height in a set of drilling operations, the retract height is set at the rapid plane, and no, it's not. It's set at the feed plane. And with the Tormach, I never had a problem with this operation because the Tormach knows how to move kind of in diagonal rapids. And when I first got the mini mill, it appeared to move in diagonal rapids. And then a couple of videos ago, maybe not a couple, I think maybe, what is it, the last video? It was sometime in the past, I don't remember exactly which one it was, but sometime in the past, I found a bug in the Haas software where the machine just stopped running, just stopped. And when I called the service tech, he says, oh yeah, that's the diagonal rapid code doesn't work, so you have to turn that off. And that means that the rapids don't move diagonally, they kind of move over and across. And with the toolpath I had set up before, this resulted in a minor little collision with the drill bit and the protruding boss. Didn't break the bit, it did ruin the part, but oh well. So I ended up wasting a whole bunch of time doing that. And then I also kind of got this wild bug up my butt that I wanted to investigate scripting in BobCad, and that's even more poorly documented. So it took quite a lot of work, quite a lot of Google searching, quite a lot of experiment, quite a lot of guessing, and I finally figured out how to do scripting in the BobCad post processor, and I'm actually planning on writing a document called Scripting the Missing Manual. I'm not sure exactly where I'm going to post it. I'll probably post it on machinist forums and on my own website. But I think the BobCad has kind of like their business model is sell the software at a reasonable price and then sell you training at a higher price. And for me, I don't need no stinking training. I can figure it out. I've been figuring out software since 1972. and I can figure out anything usually. So I figured it out, and who knows, maybe someday I'll actually find it useful for something. These drive rollers are going to be made in a somewhat different way this time. In the past, I would cut the blank on the Tormach and then mill the groove, the O-ring groove around the outside, mill that on the RapidTurn CNC lathe attachment. Well, don't have that thing anymore, so I'm going to try using a kind of an 1/8-inch carbide slitting saw after the outside is finished to make it round. I'm going to try using the slitting saw to cut the O-ring groove, and we'll see how that works. But for today, just going to be roughing, drilling, finishing, first operation. So I've got 4 parts clamped in the vise at the 4 different work offsets and have set up the array function. I'm also trying to see, how much can I push this thing? What are the limitations of the machine? How aggressive can I get before I start breaking cutters? And well, I have broken some cutters. Haven't done it on camera because I'm not using the camera for everything I do. I do a lot of stuff off camera, and my little cutter breaking problems occurred off camera. What most often happens is when I'm trying to be very, very aggressive with cutting, these cutters that I'm using have a kind of like a spiral flute, which means that not only are they generating forces in the XY, but they're generating Z forces that tends to pull the part out of the vise. And so even though the soft jaws are aluminum, the parts are aluminum, and bare aluminum against bare aluminum has an exceptionally high coefficient of friction. It's one of the highest, if not the highest, coefficient of friction between two metals. You gotta have, it's gotta match, it's gotta be accurate. And when I had a problem with pullout, it was because I cut the blank on the table saw, and even though I'm really good with a table saw, and the table saw is in really good condition, new blade, part looked perfect, sides really weren't parallel. So for this setup, these are parts cut from the same extrusion, and within the distance that these blanks were cut, they're all cut one after another consecutively. They're not just being picked out of a random box of blanks. So within those 4 consecutive blanks, I'm assuming the tolerance is going to be pretty close, and the vise does have a tiny bit of wiggle side to side, which is why it's good to balance. When you're clamping tightly a small part, it's good to have small parts on both sides to balance it. So I'm using the Lakeshore Carbide aluminum shredder 1/2-inch 3-flute end mill to do the roughing, and I'm doing it reasonably aggressively. I haven't tried pushing it all the way to the limit because I don't want to break my cutter. I've only got one, and so I'm kind of like debating with myself, how far do I push it? And well, here's where I settled right now, which is, I believe, 200 inches per minute and a 30% step over on the spiral pattern, and it cuts pretty fast. I'm also starting to wear plastic gloves, and in the past, when I'm handling parts that come off the machine, haven't been deburred yet, I get these annoying little scratches. They're not deep, they're not serious, but they sure are annoying. And I've been watching a bunch of the A-bomb videos, and he says, oh, get these gloves. So I got these gloves. We'll see if that maybe reduces some of the annoying little scrapes and little scratches. So I'm going to put on the safety glasses here. I've also got the GoPro. I figured out how to lock the back screen, so I'm not going to inadvertently put the thing into time-lapse mode, which was a problem on one of the previous videos. So this has already been tested. Like I said, I've been working all morning. I wasted pretty much the entire day just dicking around, fighting BobCad, trying to make the most efficient toolpath possible, and tried maybe, I don't know, 6 or 7 different procedures with 2D, 3D, HSM, no HSM, adaptive roughing, spiral roughing, and then, so anyway, this is what I ended up with. Appears to be working pretty good, so get this guy going. $10,000 RPM, 200 inches per minute. About 66% spindle load, which means I can probably bump it up a little, but then I'm always concerned about, well, is the vise going to hold the parts, or am I going to get pull-out problems? So, of course, it's always the question, how far do I need to push it? How aggressively do I need to cut? I mean, this is going reasonably fast, and I'm not sure I'm going to continue dicking with it. I may just leave it like it is. But then again, 160 parts, maybe if I can shave a few seconds off, I'll be in a slightly better place. So, drilling here at 5,200 RPM and about 20 inches per minute feed, which is it's a little bit over the recommended feed and speed for high-speed drill bit. It is a high-speed cobalt drill bit, so I may be able to increase the aggressiveness on that a little bit, but hey, it's working pretty good. So the array operation is working correctly. Very nice feature. As I said before, in the past when I was trying to do multiple parts on the Tormach, I actually ended up making CAD drawings and tool paths of the array of parts as they were positioned in the vise, which is a lot more work. And with this method, it allows me to perfect one tool path at one work offset and then just automatically duplicate them. And then the only thing I have to get right is just to make sure my work offsets are okay. So, drill some holes. The center hole will be reamed, and this is the, what is it, the 23/64 drill bit that gives a 64th over for reaming, or 64th under for reaming. A 64th over wouldn't be very useful, now would it? So here comes the 3/8 reamer, 250 RPM, 30 inches per minute. I bumped it up a little bit from where it was on the Tormach. Still turning it fairly slow. I don't want to turn the reamer too fast. So now I'm going over to the 1/2-inch 3-flute Lakeshore Carbide finishing mill, and this is running at 100 inches per minute with almost no spindle load. I don't want to run this one too fast just because I kind of want the surface finish. And that's about it. There's really nothing more to say about this. So there we have it. One slight annoyance about these parts that when I don't know if you can see here, but I'll hold this up to the camera. The bottom of the part ends up, it's somewhat clean, but it's not that clean. And when I'm deburring by hand with the Noga deburring tool, I'm holding these sharp edges, and that'll be an interesting test to see if these gloves really do prevent fingular irritation. In the past, I've ended up irritating my fingers, getting minor little scrapes and cuts and stuff, especially on the corners of these parts. So I'm going to run the rest of the batch, and that's going to take me a few hours, even at a 4/16 cycle time for 4 parts, so that's roughly a minute per part. And then I need to, while the parts are being made, I need to cut blanks, I need to deburr blanks, I need to deburr parts, and I'm going to be doing this for a while. And then the next time I turn the camera on, I'm going to be showing the hopefully very successful slitting saw construction of the groove. And if it doesn't work, well, I'm going to need to come up with another solution. I'd hate to have to do all these on the manual lathe. Boy, that would be a royal pain in the anastomosis. So I'm going to turn the camera off and run some parts and come back. First operations are complete as far as I could complete them. I kind of ran out of material. I guess I just didn't. Oh, I don't know. Sometimes I make mistakes in places I'm not expecting to make mistakes, but I ran out of material, so next time I go to the aluminum supplier, I got to pick up a couple of more sticks. Anyway, the next operation, in the past, I performed this operation on the Tormach RapidTurn. And for those who don't know, the RapidTurn is a kind of like a minimum, kind of limited CNC lathe attachment that fits on the mill table. It's got a motor and it turns, and it connects to the Path Pilot controller and provides kind of like CNC lathe-like capabilities. The tool holder is mounted to the machine spindle, obviously not rotating, and if you take really, really light cuts and go really slow and be really careful, it actually works. But the Tormach is long gone, the RapidTurn is long gone, and I sure don't want to make these grooves in these drive rollers on the manual lathe. First of all, because I've got 160 of them to make, and second of all, I really want them to be exactly the same diameter. And doing it by hand, yeah, if I take my time and really, really pay attention, I can hold any tolerance I want, but that's no fun. I want to get this production run done. So I'm using a Carbide Slitting Saw, and this guy is 2" in diameter, and it's 1/8 of an inch thick, and the O-rings are nominally 1/8" O-rings, but if you measure them, they're actually 1/35. And so in order to make it easier to put them on, I usually make the grooves to match the O-rings. So I usually make the grooves 1/35, which means I need to do 2 passes with an 1/8" cutter, and hey, that's not a problem. I made a fairly elaborate fixture here, milled out of a piece of 1" thick aluminum, where I have alignment pins that I machined on the lathe and then secured in place with Loctite retaining compound. And I'm also using 3/8 diameter shoulder bolts, shoulder screws, which are made to a pretty high degree of precision in their diameter. The holes were cut on the machine in the same place that I'm going to be using the same work offset and the same probing and all that, that I'm going to be using to actually cut the diameters. And the surface, both top and bottom surface, were skinned with the face mill. So this is the most elaborate and I believe the most accurate fixture that I've ever made. The holes for the the holes for the shoulder bolts were drilled and reamed, so it's about as accurate as I can make it on this machine, because obviously the grooves need to be concentric with the center holes. So the center holes are drilled and reamed. They go on very nicely. I mean, that's a really nice fit on those shoulder screws. And then go along with my aluminum spacers and nuts. And I don't want to like totally crank these to the limit with the torque driver, but I do want them to be secure and not come out. So this will be using the BobCad array function, and I've already made a few, so I know it's going to work. There's no surprise coming up here as I try to figure out, hey, is this thing going to work? So I'm using the BobCad array function and using 3 very special work offsets that I never use in my normal arrays, but since the mini mill supports, I think, 20 additional work offsets in the G154P 1 through 19 or 1 through 20, I got no problem. I'm not running out of work offsets. So let's get this guy going here, and then I'm gonna just take a look at the screen and just make sure that I'm not making a mistake. But here we go. 4 drive rollers. Using the Lakeshore Carbide aluminum shredder roughing tool at 200 inches per minute, doing a kind of a spiral pattern here. And yes, I did check the retract height, because running into those screws with that cutter would not make my day, I tell you. So that's one of the things that I have to be extra careful about, is running into my tooling when I'm doing rapids. So we're roughing here. And then I'm going to finish the outside edge with the Lakeshore Carbide 1/2" 3 flute finishing cutter. And of course, all these cutters are running at 10,000 RPM. I really, really like the 10,000 RPM spindle. At first I thought it would only be useful for small cutters, but it turns out that it's really useful for just about every milling operation I do. Well, at least every milling operation on aluminum. When I get to making my steel parts, I'm going to do the appropriate feeds and speeds for the cutter and the material. So now here comes Mr. Slitting Saw, which is a solid carbide slitting saw. And this is going at 2483 RPM, which provides the appropriate SFM and feed per tooth. Actually, I didn't calculate feed per tooth. I just kind of guessed, because it's a 100-tooth cutter, and I'm probably running way slower than I could if I used the recommended feed per tooth for a carbide cutter, but I'm just a little bit nervous about running this guy too fast. And who knows, maybe I'll bump it up a little bit as I go. But for right now, it produces a beautiful surface finish and great accuracy. I took a couple of precision dowel pins, what are they? Precision pins, I'm trying to remember, gauge pins. Grabbed a couple of precision gauge pins in a micrometer, and the diameter of the groove is dead on within the accuracy of my micrometer. So this should all produce great results. The next operation after this I'm not going to show on camera because it's pretty boring. I put the roller in the Bridgeport and drill the hole for the set screw perpendicular, and that's not that interesting. So there we have it. Drive roller outside array, and that will do it for today's video. The project is going exceptionally well. The mini mill is, what a magnificent machine. If they just, got rid of a couple of the software annoyances that bug me, damn thing would be perfect. But little bit by little bit, I'm working around all of the annoyances and just, learning to follow its rules. And I'm in wrong mode less often than I was before, although, if I was writing the software for this, it wouldn't have as extreme modal behavior. So anyway, that does it for today's video. See you later. It's been fun.